Hi students, let us continue with the COCOMO models. So I said the COCOMO includes three types, that is three different types of models, that is a basic model, intermediate model and the detailed model, that is a complete model. Now let us see first model, that is a basic model. The basic COCOMO model takes the form of E is equal to AB KLOC, that is a kilolo BB, and whereas D is equal to CB EDB. So these are the formulas for calculating the basic model, the cost estimation for if you use the basic COCOMO model. So here E is the effort applied. Effort applied. E means the effort applied to a product or a project. So this is the formula. And whereas D is nothing but is a development time. It's a calculating the development time of a product. Okay, and here the people required, the people required, P is equal to effort applied by development time. If you know the effort applied on the project and if you know the development time, then you can get the people, how many people are required to develop a product. So these are the three formulas that are used to calculate the basic constructive cost of a product. Okay, and here AB, CB, DB, and here BB also is there, BB, or coefficients. So there is a standard table for whatever you are using, the standard coefficient values for this A, B, C, B, D, B, B, B. For all these coefficients, there is some standard variable. So whatever the project you have taken, there is a software project that you are using the organic, semi-detached or embedded classes. Let me explain that. If you're suppose you're using the basic COCOMO model, so in the basic COCOMO model again this can be applied in organic mode, or it can be applied on semi-detached mode, or it can be work on embedded mode. The software project can be work on this organic mode, semi-detached mode, or embedded mode. Okay, and the coefficient for this is AB, BB, CB, DB, and the constant values for this or let me write the constant values for this. Organic is 2.4, BB is 1.05, CB is 2.5, 0.38, 3.0, 1.12, 2.5, 0.35, 3.6, 1.20, 2.5, 0.32. So these are the standard values for whatever you have taken the variables, whether it is a basic COCOMO mode or intermediate or whatever you have taken. So for all the software projects, if that project is working on the organic mode, means the small project, if you are using, you have used this value. If you are using the medium sized project, then you can use this. If you are using these large projects, that is embedded, you can use these coefficients. Okay, so this is a formula for calculating the basic COCOMO model. Let me explain with an example. Okay, so here is an example for basic model. Suppose that a project was estimated to be 400 KLOC. Means here that is a KLOC, that is line of code they are given. Means the total size of the project they are given. So if you know the size of the project, then we can find out the effort that can be applied and the development time it takes to complete the project. Suppose a project was estimated to be 400,000 lines of code. Now calculate the effort and development time. So we have to calculate the effort and development time for each of the three So for all these three, we have to calculate the effort and development time. In the case of organic, means the small projects. In the case of semi-detached, intermediate projects. In the case of embedded, large projects. So if you are using the basic COCOMO model, you have to calculate the effort and development time in these three classes. Now let's see the basic COCOMO equation, that is E is equal to AB K LOC B. Okay, so this is the effort required, effort applied. And next is the duration. So sorry, not D is not, it is the development or duration, whatever it may be, sorry. Duration time or development time. Sorry, this is not KLOC, this is the E, the formula E. First, if you find out the E, effort applied, then by putting the effort here, we can calculate the development time. So this is the formula, and the estimated size of the project they are given, that is a 400 KLOC. So here the estimated, they are already given. Now calculate the estimated time and the development time in the case of organic, semi-detached and embedded. Just substitute the values. Actually, E is equal to AB K LOC P power B. Okay, here I am writing that 2.4 AB. So how? So already I have noted the values. See here. So in the basic mode, the values they are already given, that AB. What is the value of AB in organic? 2.4. Just substitute 2.4. And the value of BB. In the organic case, the value of BB is 1.05. So just substitute 1.05. Then you will get the effort person month in the terms of person month. And in the same way, the duration. The duration formula, development time formula is D is equal to CB E power DB. So what is the value of CB in organic? 2.5. Just substitute 2.5. And the DB is 0.38 in organic. 0.38 substitute. And you will get, this is the development time. Now coming to the semi-detached. So the same formulas, but the values will be changed. The coefficient values will be changed. So what is the value for semi-detached AB? 3.0. Substitute 3.0. And the BB 1.12. So substitute 1.12, then calculate. For the development time CB is 2.5 and DB is 0.38. So just substitute those values and calculate. So here you require only this. So in the case of embedded, so D is equal to E is 2462.79 and power of DB is 0.35. Here I have to write the 0.35 because the power of DB. And the same way embedded mode. So just substitute the AB values, BB values in the embedded by seeing the coefficient table, and here the substitute CB value, DB value, and here D. So this, then you will get the effort time for organic mode and the development time for organic mode, effort time for the semi-detached mode, development time in the semi-detached mode, effort applied in the embedded mode, and the development time in the embedded mode. So this is the example for the basic mode. Thank you.